So today we're going to be solving inequalities, compound inequalities. Here I just started with a regular inequality because I believe you have one of these on the quiz. So just getting variables on one side, numbers on the other. So we're going to distribute. We're going to get 10x minus 30. Distributing our negative 7, we get negative 7x minus 49 is greater than 4x. I like to simplify. You don't necessarily have to, but I think it's easier if you do. So combining my x's, 10x minus 7x is 3x. Negative 30 minus 49 would be negative minus 79, greater than 4x. I need to get my variables on the same side, so I'm going to subtract 3x from each side, and I get negative 79 is greater than x. Which is probably fine to leave this since it doesn't tell me to graph it. The next one, though, does tell me to solve and then graph on the number line. And this is a compound inequality, so we have to remember that this is an and when the and isn't written in, so we have to break it down into its two parts. 7 is less than x plus 2, and x plus 2 is less than or equal to 11. So solving this, we would subtract 2 from each side and get 5 is less than x, but here I am going to write it x is greater than 5. That'll help me when I get ready to graph here in a minute. Subtract 2 from each side, we get x less than or equal to 9. This is an and, so we are graphing the intersection where these two overlap. Please make sure you graph below the two parts and then the solution above. Greater than 5 does not include 5, so we have our open circle and then going to the right. Less than or equal to 9 does include the 9, so we put a colored in dot where the 9 is, and less than would be going this direction. So we want to see where these overlap or intersect, so it would be from 5 to 9. Does not include the 5, but does include the 9. Okay, here we have an OR to solve. So we start the same way, it's just the graphing that's different. So we're going to subtract 4 from each side and get negative 3x is less than 15. Divide by negative 3, and here we got to remember, anytime we multiply or divide by a negative, we reverse our inequality. So it's going to become greater than negative 5. Here we add 3 to both sides. 7x is greater than 21. Divide by 7. Here we're dividing by a positive, so we do not reverse it. Greater than 3. So we want to graph both of these. Alright, greater than negative 5 does not include negative 5, but go in here and make your graph long so you can see everything. Greater than 3, don't have much room for that, but it's going to go here. But if we put these two graphs together, what numbers are covered? By one or the other. Doesn't have to be covered by both this time. So it would be from negative 5 on out. So we want that one graph, if at all possible, on top. And now we come to ones that involve absolute value. So remember, there's two situations to every absolute value. It is a compound inequality, and you will have to write it as such. So this is a greater than, so greater is the clue there that I've been trying to get you to use, so it's going to be an or, so we're going to break it down and write first just the regular 2y plus 5 is greater than or equal to 7. And we do need the word or, same thing again, 2y plus 5, we reverse our inequality, less than or equal to, and we take the opposite of the number on the right. Now we just go about solving the normal way of solving. So we subtract 5, we get 2y greater than or equal to 2. Divide by 2, y greater than or equal to 1. Over here, when we subtract 5, we get 2y less than or equal to negative 12. Divide by 2, y less than or equal to negative 6. So that's just the same things we've been doing. Now again, this is an OR, so when we graph it, we're graphing the union of the two. 6, 2, 3, 4, 5, 6. Graph the part below, so greater than or equal to 1 would include 1 and all numbers to the right. Less than or equal to negative 6 would include negative 6 and all numbers to the left. So to put these together, what are covered? Well, really it's just the same graph again. So sometimes that happens, not always, but sometimes. So that would be our solution to that one. Alright, now we have a less than is an and. So again, we put it down into its two parts. 3x plus 4 is less than 8, and 3x plus 4, reverse your inequality, greater, take the opposite of 8, negative 8. So we just go about solving these, subtracting 4 from each side. 3x is less than 4. Divide by 3. You get x is less than 4/3, which you can think of as 1 1/3 when we go to graph it here probably in a minute. You can read that. Here we subtract 4 from each side. Negative 8 minus 4 would give us negative 12. Divide by 3, and we get x is greater than negative 4. So when we graph this, we're going to graph the intersection. So less than 1 1/3, so open circle going that direction. Greater than negative 4, open circle going that direction. Where do they overlap? Between negative 4 and 1 1/3. So that would be the solution. All right, here's a word problem. We really haven't practiced too many like this, but this is very similar to what we've done before. It's just an inequality. The sum of two consecutive positive even integers. So we have to define our variable. I'm going to let x equal my first positive even integer. So I need to put all that in there so I know what I'm looking at. Now I want to find two of them. Well, what's the next even integer after x? Well, even integers are 2 apart, so it'll be x plus 2 is going to be my second positive even integer. And I want to know the sum of these two is the most it can be is 15. So sum means I'm going to add, so x plus 2. Well, if the most it can be is 15, it'd have to be less than or equal to 15. So we get 2x plus 2 is less than or equal to 15. Subtract 2. 2x is less than or equal to 13. Divide by 2, and I get that x must be less than or equal to 6.5. Now this is why it's so important to define your variable, because we see what other possibilities we have now, because we have to go back and see what the variable must be. So the variable must be this, less than or equal to 6.5, but it also must be these two things, or this thing up here, positive even integer. So what's a positive? Let's take the largest positive even integer, less than or equal to 6. Well, it would be 6, and 6 plus 2 would be 8. So that would be one combination. Are there any other positive even integers less than or equal to 6.5? Well, yes, 4 is. 4 plus 2, 6. Are there any others? Yes, 2. 2 plus 2 is 4. Are there any others? Would 0 work? No, it's even, but it's not positive. So these would be my 3 pairs. So it did say find all possible pairs of integers. So you can't just stop with one of them on this.